Hello. Hello.
Hello, Uncle.
Hi, Karishma. How are you?
I'm fine.
Yeah, sorry. Got a bit
Yeah,
late. Yeah.
no problem.
Yeah.
Uncle, I tried the 10th question.
Okay.
Yeah, but I didn't get it. I'll just send the picture.
Okay. Send it in the WhatsApp.
Yeah.
So other all problems you could proceed, right?
Yes, yes.
Okay, good. Okay. Yeah, it's downloading. Anyways, my desktop is a bit slow compared to the.
Okay.
Yeah, okay. Okay. Let's see the. So you started with the component of the forces horizontally and vertically,
Yes.
right? And also even for that there has to be a rationale behind why we do that, because they said that in the problem the particular object is moving horizontally, right? Sliding horizontally,
Yes.
isn't it? So that is the reason resolving horizontally and vertically will help us. If it is some inclined plane or something like that, then we will be resolving along the plane
Yes.
and perpendicular to the plane. So that itself is good. The beginning is good. And okay, so let me see that. So you say that, okay, reaction is actually compensated by the weight, right?
Yes. Sir.
And you are saying that friction is okay. Okay. So the frictional force is going to be 2.5 Newton.
Yes.
Then the air resistance is okay. So you proceeded.
After that.
Yeah. Yeah. Why you can't proceed after that? Because you say that the R value must be equated to the one going down, right?
Yes. Sir.
The attractive force, the gravity, which is pulling it down to the center of the earth. So you missed the, why you put 5 and you add mg and.
Uncle, your voice is breaking. 1 second.
Yeah. Hello.
Yes, sir.
Yeah. So why you first wrote it as a mg, the gravitational force, and then you cancelled and you wrote it as a 5.
Because I knew the answer for it. Because it was 0.5 into 10. Because I'm into G. That's why.
1 second. Let me catch the problem. Because where is the problem? Okay, okay, let me see that. I sent the force problem to you, right? Like
Yes.
yeah, but okay, it is not there. Let me check where I kept it. Because let's extend that particular problem, then we could proceed with that. As you did for the vertical one, and you should do the same thing for the horizontal, right?
Okay.
Similar thing, not the same thing, means similar thing, what I mean.
So will it be 2.5 plus 0.05 V square will be equal to
Just
10.3?
don't put to numbers, okay, come on, be careful, because numbers are all fine, because this looks like you are more happy with the numbers, like you go with a number, then the problem looks like more like a problem is solved. You feel more comfortable with the numbers. It's a thought process like that, right? Isn't it?
Yes.
Because I mean, you went directly like, okay, mg I know and everything, but okay, I need to first see the problem to tell you that whether what you did was going in the right direction or not.
Uncle, do I send the PDF to you?
It's okay, I got it. One
Okay.
second. I don't want to have the whole PDF. Let me send you the. Yeah, the block of mass m 0.5 kg starts sliding horizontally at a speed of 10 root 3 meter per second on a flat surface with the friction coefficient mu equal to 0.5. So the first line itself is telling us there are going to be something happening with the particular object, right?
Yes.
So we need to start from there. Like that is what helps us to actually capture everything happening with that. Okay, let me see whether I could get it here in our whiteboard. Let's start the. Okay, can you see the whiteboard?
Yes, sir.
Okay, let me see whether how much I can. Okay, I pasted something. How much I could do that, I'm not sure. Let's see. Okay, not that bad. Okay, so we got at least something. Okay, can you see that?
Yes, sir.
So a block of mass, let me correct that, 0.5 kg starts sliding horizontally at speed, let's say it is going to be 10 root 3, right?
Yes, sir.
So 10 times square root 3, right?
Yes, sir.
Square root of 3. Okay, and the meter per second. On a flat surface with a friction coefficient, okay, that is also giving some information, 0.5, isn't it?
Yes, sir.
Okay, so the mu is going to be 0.5. Numbers are all okay. So even what I would do horizontal at speed, because there is a friction going on, right? So
Yes, sir.
I'm still working on the first line itself, because I try to maximize everything what we could do with the understanding of the first line information translated to a level that we could be going further with the problem. Do you catch that?
Yes, sir.
Okay, so m is already given. M equals, so m is a parameter which is available. Horizontal at speed, it starts, you see the clue, starts sliding horizontally at speed. That means what?
So U is 0.
No, U is not 0. Starts sliding horizontally at. Do you get that?
So okay. So it will be 10 root.
Why? Tell me, why you thought that, why you should be 0? What made you to think that? What made you to, for this particular problem? Because you see, most of the time, the thought process will force us to push something which we are more comfortable. Do you get that?
Yes, sir.
Okay, but we are not going with what we are thinking or what we want, right? We are working on the problem which we want to solve it correctly. Do you get that?
Yes, sir.
And don't put any restriction or any a priori thought process that, okay, initial velocity will be 0, final velocity will be this much, I can calculate with the kinetic energy. Don't do any of that.
Okay.
All those connections and how they behave and everything, the knowledge can be there, but don't bring the knowledge force into things. Okay.
Yes, sir.
So that is why, I mean, it is very simple. The object is sliding horizontally. Okay. And
Yes.
has a mass 0.5 kg and is a fixed number. Okay. The number is going to help us a lot of things, but it is a 0.5 kg. So the mass is 0.5 kg. Mass is going to do what? It is happening on the surface, right? On the surface of the earth.
Yes. Yeah.
So what the mass will feel what?
Gravity.
Yeah, gravity. Yeah, good. I mean, be confident. Okay, don't worry about, okay, whether it is going to be right or wrong, because we need to develop that attitude. Like when I have an understanding and a clarity about something, then I know that is correct. That also need to be there. Do you get that? So this is going to be, okay, let me keep it as 3 different. Okay, the air resistance on the block as magnitude 0.025 V squared, isn't it?
Yes.
V squared and so much Newton, where V is the speed of the block. And then, okay, I split purposefully into three different lines. Okay, take the acceleration due to gravity. You see, that also giving an idea that, okay, I mean, we have to use that also. Okay, so they have used the G for that. And I would say the air resistance of the block as magnitude of this much. So I would use a F lowercase a for that. Do you see that?
Yes.
Okay, because why I am doing that? Because I will start writing things as a parametric way, variables way. And then when the number is need to be substituted, I can do that when I want. Do you get that?
Yeah.
Okay, so keep doing like that. So then we are saying that take the acceleration due to gravity. G is, this is also meter per second squared. Find the time taken for the block to come to rest. Okay, it's a simple, straightforward. If you translate everything into our understanding, then things will get much easier and simpler. Do you get that?
Yes.
So let's start doing things. First of all, I will use this information. So translate this. This is going to be M equal to 0.5 kg. That means what? There is a block and it has a M, and this is going to have a force acting in this direction. That is a force coming from the gravity. Do you get that?
Yes.
So if you call that as a Fg, that is going to be a value also. We can write it as a mg. That we know, mass into acceleration, right? Good.
Yes.
You did that and you substituted and you got a phi. Let it be. We can use that later. But that is not going inside or damaging or anything is happening to the surface. That means the surface has a hardness that can produce a equivalent reaction on the opposite direction, exactly opposite to the gravity. That magnitude also is going to be mg. You get that?
Okay.
Then only the object is not at all going up and also not at all penetrating or damaging the surface. You get that? That is why the R magnitude also should be the mg. The Fg magnitude should also be mg. Okay.
Yes.
Even in a vector way, we can say that R vector is going to be minus Fg vector. Do you see that?
Yes.
Okay, magnitude wise, but this is what is translating to as they are in equal and opposite direction. So we are saying that the magnitude of R is exactly equal to the magnitude of the Fg. Is it clear?
Yes. Yeah.
Okay, but the direction wise, it is exactly opposite. That's why minus sign is more than enough. We don't need to resolve into any angle or anything. Okay, so that is what it is. And they are saying that the frictional coefficient is mu. Why I go straight to the mu? Because we just did the R and the object is moving. So the object is sliding. Do you get that? So the object, so this one, the one going up and the one going down as a force reaction under the gravity, they balance each other. So we know all this information. So we don't need to worry about this. Do you get that?
Okay.
Because understanding is there, but that is not going to help us in any way in our thing, because the object is moving horizontally. That is the dynamics which is happening. Do you get that? And also it is, they say that it is moving. And let's say we take that this is the time, this is at time t equal to 0. You're okay with that? So I say that this is at time t equal to 0. So at that point, we are going to say that the velocity at the time t equal to 0, we call that as a u, which is going to be 10 square root of 3 meter per second. Is it okay?
Yes. Yes.
So this is a straightforward information we could have written. Initially, it starts. So that is a very good clue point. Starts mean time equal to 0. Use that understanding. Okay.
Yes, sir.
And on a flat surface with the friction coefficient. Okay, that is good. So the surface is not going to be smooth for this particular object. Okay, it is going to be bit rough, and that is going to give a friction. So if the object is moving, sliding along in this direction, for example, with the initial velocity u value given to us, what the friction will do? In which direction the friction will act?
Opposite direction.
So in this direction, we have first of all a frictional force, right?
Yes.
Let me write that as this is going to be in this direction. That is going to be my F friction, right?
Yes.
Okay. And they have given mu value as our 0.5. What the mu means? You know the connection between the frictional coefficient and
mu F is equal to mu into R.
Okay, good. So the frictional force, because of this, we know that the frictional force is nothing but the mu times the normal reaction, right?
Yes.
That makes us, this is going to be, because we already know that the magnitude of the reactional force is mg. Just use that, mu mg. Is it okay?
Yes.
That also we got. So this is everything what we got. And they are saying that, okay, I did not mean, I should have moved the motion. So this is what we are saying. So now, just to extend this thought process, think that we are the object and we start sliding at the initial velocity of 10 square root 3. Normal component, they are exactly balanced. So that is not going to affect this motion. But don't you think that frictional force will try to act opposite to that, will give a deceleration for this?
Yes, sir.
So that is why we are going to say that there is going to be a V which is going to change in time. You're okay with that?
Okay.
Is a function of time. Function of time. So this gives a very good idea. When V is changing, immediately what we will be interested? If the V is a function of time, then that leads to what about the A, right?
Yeah, so V is equal to U plus AT.
No, don't do that. Don't do that. You see, that is what you are making. Like, don't push yourself. Tell me V equal to U plus AT. When this is valid, what is the validity of this?
Uniform accelerated.
When the A is constant, do you get that?
Okay.
Only when the A is constant. So far in the reading, they are saying that the frictional force, and also, is better I kept the second line. The motion of the block is impeded by the surface friction and the air resistance. So the friction is, because the friction is not a time varying quantity. Do you get that?
Okay.
Because the friction is mu mg. Mu is a number 0.5 and m is a mass 0.5. That is also not going to vary. G is a 10 meter per second square. That is also not varying. So F is, the frictional force is independent of the time. Do you get that?
Yes, sir.
So that will be giving always a fixed amount of deceleration. Do you get that? So
yes,
how to find the deceleration value of our friction is very simple. You take the force value, frictional force value, divided by the mass will give you that, right? Because always mass multiplied by the acceleration or the deceleration is the force, right?
Yes, sir.
So the AF is going to be, like, if you substitute the value for the mu mg divided by m, that is going to be mu g. Do you get that?
Yes, sir.
So mu value is constant, g value is constant. That is not time varying. So the frictional deceleration is going to be time independent, is constant. Do you get that?
Yes, sir.
So that is okay. But this, you still, what you said, we can take the V equal to U plus AT. It all looks fine and everything. But there is a bit of a problem here, because it's not only the frictional force. There is a air resistance acting to that. Do you get that?
Yes, sir.
So that will act on what direction? So particularly this is the object, and the object is moving in this direction with a velocity which is a time varying one, that we know that is happening because of our FF, right? Frictional force.
Yes,
and
sir.
Call the force, air resistance also is a force, right? And simply
Yes,
we have given that in a value which is in terms of newtons. Don't you think that the air resistance will oppose the motion?
Okay.
That is what will happen, right? When
Yes,
the
yes.
object is moving, the air is going to block that motion. Like when we are driving in the
Yes.
car, as we go higher and higher speed, that means we are accelerating more. We are trying to give more force to go very fast. Do you get that?
Yes, sir.
But the air, which is actually blocking, because air, let's say, consider that air is still. So that means we are hitting the air molecule with a high force. That means the air molecules will going to give us a very big reaction, resistance to us. Do you get that?
Yes, sir.
And the direction of the air resistance is exactly opposite to the motion of the object. Do you get that?
Yes, sir.
Okay. So now, and they have very clearly given there is going to be a FA is not a constant. It is a 0.025 V squared. You get that?
Yes, sir.
And we already seen that the V is going to vary with respect to time. This tells us this is going to be actually this FA is a function of time. We have to be careful here. Do you see that? What I'm doing?
Yes, sir.
So the R is constant. The force that is constant, and correspondingly the mg, the FG, mg, which is actually we call that as a gravitational thing, is also constant, not time varying. And of course, the mu, the F friction, that is also going to be the fixed value what we calculated. This is also going to be mu mg, and this is also constant with respect to time. Do you get that? All of them are constant.
Yes, sir.
But this is the interesting part. The FA is a function of time. Do you get that?
Yes,
Why
sir.
is a function of time? If you substitute 0.025 V is a function of time. So we need to, this is given as this is squared. That means that is the reason the T, I am writing this because of this. Because it starts with the initial velocity 10 square root 3 meter per second. And if you completely read the problem, at the very end, they have also completed with to find the time taken for the block to come to rest. Do you see that? So the velocity starts at initial value 10 root 3 and it is going to finally become a 0. Do you get that?
Yes, sir.
Okay, so even we can draw a graph quickly to understand that, because there is going to be a V. We know that the starting value, I want to draw a V with respect to the time. Here, this is going to be a value 10 root 3. And after some time, I'm going to see that it is going to go to 0. Do you get that? And
Yes,
this is our T final. This is the time taken to complete the full motion, starting at 10 root 3 meter per second. But you are forcing it to be a straight line. Do you get that? So you are saying that this will go as a straight line. But I'm saying it won't. Tell me why. You are saying it is a straight line. And because of that, you got this equation is valid and you will proceed with that. But I'm saying, no, it won't be a straight line. Why? You already said that the A is a constant will get you this, right?
Yeah.
Okay, let me go to the new page. Can you go to the next page, please?
Yes, yes. Yes, sir.
So when you said A is a constant, that is the validity, because dV by dt, we define that as a, isn't it? So dV will be equal to A dt.
ADT.
We can calculate the dV is what? If you have a V velocity, you split into small equal pieces. Each one of them we call dV. If you integrate the dV, we get the V, isn't it?
Yes, sir.
Okay, so we do that. Integrate dV. We did a mathematical operation on one side of the equation, balance doing the other side. Now I am interested from starting from time t equal to 0 all the way to t equal to t. This is what I'm interested in. All the dynamics happening, I want to capture. from the starting time 0, reference time 0, right? So the limit
Yes,
for
sir.
this side of the integration coming from this variable. This side, the integration is with respect to velocity. So now look at a time t equal to 0, our velocity is going to be v of 0, right? So that we always call that as a u, isn't it?
Yes, sir.
And all the way to, I want to know for velocity, all the way to every velocity in time as a function of time. That is what I'm going to do as a limit. Is it okay?
Yes,
So
sir.
first to complete the integration, integration is a v, then this has to go with a limit from u to v. I mean, if you want, you can write v of t is actually equal to, a is a constant. This is where the beauty, this can be taken out, right?
Yes, sir.
That is because of this very strong consideration. Then we do the integration of the dt, that will give us the t itself, and the t will have a limit from 0 to t. So now apply the limit v of t minus u will be equal to a t minus 0. You catch that?
Yes. Yes, sir.
So that makes straight away that v of t
V minus u
is
equal
equal
to
to
8.
u plus at. That is how this formula comes into picture. We cannot throw this formula for anything what we want. Do you get that? Do you see that?
Yes, sir.
But in our problem, it is not a difficult problem. Look at here. In our problem, the block, so the vertical one, we can leave it because it's all. So this is moving at a velocity v, which is changing in time. Remember that. And it is opposed by a air resistance, which is going to be a function of time. Because this is 0.025 v squared. That is why it is a function of time. I explained you to that. And the frictional force, which is also going to, frictional force. Only the control is that is not working for me. Okay, let me erase that. Arrow mark is not right. Okay. Frictional force is going to oppose this also, right?
Yes.
Okay, so this is our FF. That we know that. So we are saying that now we have a balance here, right? Because we know the force acting in this direction, and definitely there is going to be the object is going to decelerate, and after a time, from this time, for example, t equal to 0, and it is going to come to a rest here. Do you catch that?
Yes, sir.
So this is our time t equal to tf. Well and good. And here we know that the v of 0 is going to be our u, which is going to be 10 root 3 meter per second. And this is going to become a v of t final, which is going to be 0 meter per second. Is it okay? So now when this is changing, so we know that there is a deceleration. Do you get that? Deceleration. You're okay with this?
Yes, sir.
Hello. Okay. So now what that is, the deceleration is going to have a force which is stopping this, right?
Yeah.
Okay. So what is actually that force is acting? That is our FA. So the deceleration force, I will call that as a F multiplied by whatever the FD is the deceleration force, which is nothing but the magnitude of this will be the F friction plus the FA. Do you catch that?
Yes, sir.
Now, do you see how we got the balancing force equation for the horizontal component? So this whole thing is the horizontal component. Horizontal component. Okay.
Yes, sir.
I'm spending time in explaining everything because you need to get this as a very basic thing. When you apply anything as a equation or a formula or a model throwing into something, you should not just jump into that. I know some equation I can apply wherever I want. Do you get that? Is it okay?
Yes, sir. Okay.
So now this can be written as mass multiplied by whatever the decelerating acceleration or the deceleration. We can say that is going to be our mu mg plus our 0.025 v squared. You see, we have formed an equation, isn't it? Is it okay?
Yes, uncle.
And now, don't you see that this will be the AD itself? I use it here. The AD. Don't you think that this is what we defined as our dv by dt, right?
Yes, uncle.
But when we try to integrate, that is where I said I objected. Don't integrate that with a as a constant. That's why I explained all this thing on this side. You get that? This is for constant, constant a. But now, as the a is going to be time varying, simply use this as m multiplied by dv by dt. That will help us to not to make mistake. Do you get that?
Okay. Yes, uncle.
Mu mg plus 0.025 v squared. So now we know the m value, we know the mu value numerically, and we know the m value also, we know the g value. So this is simply between the v and the time, right?
Yes, uncle.
We captured that. This is what you should have thought about and used rather than using this one, because this is valid only if the a is constant. You catch that? Is it okay?
Yes, uncle.
Okay. We catch that. I mean, why?
Yes, uncle.
Yeah. So now use the mu mg. Mu mg value is what? Mu is 0.5, right?
Yes, uncle.
Multiplied by
0.5 into 5.
5 multiplied by 10. That would give you a 25, isn't it?
2 point.
No, mu mg I'm saying.
Oh, 1 second.
The g is a 10 value, right?
Yes, uncle. But the
how much is
body
the
is also 0.5.
Okay. There I made a mistake. Okay.
Yeah.
Okay. There the data entry is a mistake. I should not have done that. Okay. Okay, let's correct that. So this is going to be 0.5 here also.
Yes.
So this is going to be 2.5. Okay.
Yeah.
For me, this control Z is not at all working. The command is it. Okay, 2.5, right?
Yes.
But look at here. We have a differential equation. Do you see that here? What I mean is dv by dt is equal to the other side is also having it. So we should use the method called separation of variable. Do you know that? Separation of, which always we do, separation of variable. Okay. What it is, you see here also we have a differential equation. Do you see that? dv by dt equal to a. Then we grouped the v on one side and the t on other side. Do you get that?
Yes, uncle.
All belongs to. That is what we need to do here also. So it's same thing. So we have a m. So it will become m dv divided by that whatever the mu mg plus 0.025 v square, because these are all related to the v. Other side will be simply our dt. You're okay with this?
Yes, sir. 1 second.
Yeah.
Okay.
Because I just kept the m dv numerator this side.
Okay.
And this side denominator dt I brought to the other side. And other side complete numerator mu mg plus 0.025 v square come to the denominator. Is it okay?
Okay. Yes.
Okay.
But
so
v square, I just have one doubt. V square, is it like 0 square?
No, that is the time varying one, right? That is what this guy is always time varying. This air resistance. This is what is given as our 0.025 v squared. That is our v of t squared. This is the time varying one.
Okay.
Think about this. Okay, that is what I explained to you. When we try to go very fast in our car, we give more force, right? More acceleration.
Yeah.
But how much amount of acceleration we give, that force value, that is how the air resistance will react to you. Do you get that?
Yes, sir.
So that is what normally in reality it will happen. If the car is stationary, then that means what is the air resistance given to that? Zero. Because the
Okay.
object is not at all moving. Do you get that?
Yeah, okay.
When you start moving and go at a very small speed, the air resistance will be small like that. But when you go at higher speed, the amount of air resistance will increase also.
Okay.
So here they are simply saying that the air resistance, in this case, air resistance is proportional to V squared. That's it.
Okay.
Catchy point here. So it is not directly proportional. It is proportional to V squared. That is the only difference. That's it. Whatever is available and given to you, we have to just use it and let the mathematics take care of that. But only thing is, when we make the mathematical model, we should not just to force it like V should be equal to U plus AT, because that is where the mistake happened.
Okay.
Okay. So now when we substitute the value, this will look like 0.5 dV divided by our mu mg is a 2.5 plus 0.025 V square equal to dt. You catch that?
Yes, sir.
This is much more direct mathematical problem because we need to integrate both sides to get our problem solved, right?
Yeah.
Okay. Can I go to the next page?
Yes, sir.
Okay. So all we have is a 0.5 dV. So carefully we considered everything in the 2.5 plus 0.025, 0.025 or 0.5? 0.25.
0.025.
25. That is correct, right?
Yes, sir.
Yeah, V squared is actually equal to dt. So now this is a pure mathematical problem. Do you see that?
Yeah.
All we need to do is, if you integrate both sides, we will be good. So that will look like integral 0.5 dV divided by 2.5 plus 0.025 V squared equals integral dt. So now we want to capture the complete dynamics. We will start from time t equal to 0 to all the time I want to understand how the dynamics is varying or changing. Now, when time t equal to 0, we have I write as a u, but we know that that value is given to us, that is 10 root 3. You get that? Meter per second.
Yes.
And I want to know everything about my velocity. That is our v, p of t, time varying one. Is it okay?
Yes, sir.
Beauty. So now I will just take, because I'm going to look at this integration. This integration is not looking very good, or in the current form, it is not giving us straight away how to integrate. You get that?
Yes, sir.
Okay, let me do a bit of a thing to get you to give a thought process how to make a practically useful mathematical model coming into a form of this integration. Let's take this part alone. Okay, we can apply the limit later. Let's take this part, 0.5 dV divided by our 2.5 plus 0.025. You get that?
Yes, sir.
Okay. So for this, look at here. The integration is going to happen with respect to the variable v. Do you get that?
Yes, sir.
And what is the other places where the v is appearing is in the form of 1 over some constant plus some constant multiplied by v square. Do you see that?
Yes, sir.
That is a clue. So this whole integration, you should immediately see that or feel it like this is an integration, something like dx over 1 plus x square. Do you get that?
Yes, sir. Okay.
But the number we can handle it later. But I'm saying that at least something like this. Do you get that? It's an equivalence. You don't need to, the number 0.5, 2.5, 0.025, all of them make it look like much more difficult integration. Do you see that?
Yes, sir.
But this whole thing can be translated. Even I would say that this can be written as something like Okay, even I will put it as a something like a here. Okay, that will make much better, right? That makes more sense. Is it okay?
Yes.
Okay, so how to match this? All we need to say that first of all, the 0.25 we don't need that in the numerator. Do you get that? I'm going to divide numerator and denominator by 0.5. You're okay with that? So this will look like integral dv divided by, if I divide 0.5 in the denominator, that will become what? 0.2, that will be 0.5 here, right?
Yes.
Okay, and 0.025 divided by 0.5 will give you what?
0.025 divided by
0.5. That will be 0.25 divided by 5.
Yes.
That would be
So 0.05.
0.05.
Yeah.
Double checked it.
Yes. Yes, sir.
Yeah. Okay. Okay. So now you see there is a we want this whole thing to look like a variable square. Do you get that?
Yeah.
So let us do that. Okay. So the integral dv divided by, this is a 0.5 plus this quantity is going to be our, so let's get the 0.5 factorized. Do you get that?
Okay.
I would, because denominator I want to look like, so this 0.5 multiplied by 1 plus, if you factorize 0.5, what we will have in the denominator, I mean the 0.05, if you factorize 0.5, so why you take this time? Okay, let me do it in a different way. You are not sure about factorization. Factorization you should be good at, right, at your level. Okay.
No, like, can you repeat the question? Like,
no, we are doing something, but I in the way I have written itself, you should know what we are doing, right? Okay, I just took it out. Okay, so let's look at here. Okay, so the I was trying to, okay, let's do this. Let's factorize the 5. Let's see whether you can do that easily. 5 means it will be 0.1 plus.
oh, okay, you're taking it out. Okay. Sorry,
okay.
okay, I didn't realize what you're doing. Okay.
No, the realization is not because I say so. Also, I'm writing something, right? The write-up thing would have helped you to do that, right? Okay. So I did an extra step here. So this will look like integral dv divided by 5 multiplied by 0.1 plus this 0.01 is nothing but 0.1 multiplied with 0.1, isn't it?
Yes.
Okay. So this is the whole thing completing here, because that is just waiting outside. So this whole thing is going to look
take
like
0.1.
Yeah, so this is all equal. Okay. So here
Be
this
0.5.
Yeah, so that now we can say that this is going to be integral dv divided by, I'm going to say that this is going to be even we could have kept it like that. It is okay. Let it be
0.5 into 1 plus 0.1.
Because I want to make this, because we want this side to be x squared. So I don't want to, I want to use that as a good part. Get that?
Okay.
Okay. So rather I would do like this. This is a 5 multiplied by 1 over 10 plus v square by 100. You're okay with that?
Okay.
That looks better, right?
Yes.
Okay, so now I go for integral dv divided by 5 times. Now I could write this as 1 over 10 plus v over 10 whole squared. Is it okay?
Okay, yes.
Okay. Now you see beautifully things are popping up. So now this can be also written as 1 over 5 can be taken outside. Right?
Yeah.
So integral dv divided by, and we could write that 1 over 10 can be factorized, right? No, we don't need to do that. We have a, yeah, let it be. Yeah, this is okay. So all we are saying that this is going to look like our 1 over 10 plus v over 10 whole square. Is it okay?
Okay.
So this is looking like, when we compare this with this, do you see that? All we are saying that this is actually, forget about the 1 over 5. All we are saying that this A looks like our 1 over 10 and X is looking like V over 10. Is it okay?
Yes, sir.
Okay. So I will just, I am just saying we are more important here to look at how to get this integration done. Do you get that?
Okay.
Okay. So now actually I should have, it should give me that. Why it is not? Everything is okay, right? I have not made any mistake anywhere, right? 2.5.5, 1 over 10. Yeah, that's okay. Okay. Yeah, it's okay. Okay, let it be. So now let us look at here. Okay. So let's say if you have a integration like this, how to go about that? Okay. So integral dx over a plus x squared. Okay.
Yes.
Okay. Now, first of all, okay. First of all, let's factorize the a. Okay. Integral dx divided by a times. So we can take a 1 over a outside. Okay.
Yeah.
So that will become 1 plus, I would even write it as a squared. Okay, let it be. So, let's write it as a squared here to make it look better. So this a squared is our 1 over 10. Is it okay?
Okay.
Okay. So why I am doing that? Because I will factorize the 1 over a squared. So this can be written as x over a whole squared. Is it okay?
Yes, sir.
So this can also now look at here as this whole problem can be seen as something like integral dy divided by 1 plus y squared. Is it okay?
Yes, sir.
So, you know why I'm doing that, right? Because I want to make it look like a way that can give us a clue that how we can proceed with the integration.
Okay. Yes, sir.
Whenever we have this kind of thing, like something 1 added with a y squared, this is actually to be seen as a 1 squared plus y squared. You get that? Okay.
Yes, sir. Okay.
So when you have some 2 quantities squared and added, that should immediately click you the Pythagoras.
Okay. Yeah.
Pythagoras theorem. Where that leads to all the way to cos square theta plus sine square theta is equal to 1.
1.
That. This is a very good thing. In integration, this will help you a lot. Do you get that?
Yes, sir.
So somehow, you see, if this whole thing 1 square plus y squared, if you could make it as a 1, we won't see this whole integration is a difficult job, right? Do you get that?
Yeah.
But that is what this is saying. You take one quantity square plus add with another quantity square, I will be a 1. But it should be in the form of cos square theta plus sine square theta. That is what it is, isn't it?
Yes.
Here we have 1 plus something squared. So try to do that. So let's divide this by cos square theta. Okay. So what that will give us 1 plus our tan square theta will be equal to secant square theta. You see that?
Yes, sir.
Okay. So that is what we are going to do now. So integral dy divided by, sorry. No. Because the integration can be done by substitution. You guess that?
Yes, sir.
Okay. So all we need to do is, let's say if I use the y is going to be my tan theta. Straight away, I am going to the problem. So if I make the y to be tan theta, then 1 plus tan square theta will look like 1 plus y squared. You get that?
Yes, sir.
Then the problem will be solved, isn't it? So this gives us straight away 1 plus y squared will be equal to 1 plus tan square theta, which is actually equal to secant square theta. Right?
Yes, sir.
So in the, you know how to do the integration by substitution. Have you done that? We have a dy divided by 1 plus y squared, right? We want this integration to be done, isn't it?
Yes, sir.
So we are doing in this form, in the y form, we cannot get the integration done, but in the theta form, we can get the integration done. That's why we have gone for, this is called the substitution. Okay.
Okay.
Substitution. So how to handle the substitution? Now everything in the integration, which is all in the form of y, has to be changed to theta. Then that will be completely changed to theta. Is it okay?
Yes.
So already we have calculated the 1 plus y squared we calculated, but we are yet to calculate the dy. Do you see that? There is a
Yes,
y
sir.
attached with the small piece of the y is still waiting. So use that. So we know that our y is actually equal to tan theta. Then how to find the dy? It is simply differentiate the, we are differentiating the y. This is called implicit differentiation. You know that, right?
Okay.
So the tan theta differentiation is what? Tan differentiation is?
Tan theta is secant square.
Okay, so you know why it comes as a secant square? Do you know that? So it is secant square theta, that is correct, but you should always ask the question because it is not, don't ever take anything as a formula. So, but still we need to find this multiplied by chain rule. D theta should be still there. Do you get that?
Okay.
Because this side we differentiated completely, y is the only variable and dy is the differentiation of y, but other side, tan theta is having a variable theta, so it will get differentiated to secant square theta multiplied by the differentiation of the theta. That is what we get it. We get that?
Yes, sir.
Now integral dy divided by 1 plus y square will now look like integral, substitute the dy here, that will be secant square theta, secant square theta multiplied by d theta, whole thing divided by 1 plus y square is our secant square theta. Do you see that?
Yes, sir.
So beautifully, this will be cancelled with this one. This is simply integral d theta, which is theta, the answer itself.
Okay.
The theta itself. So simply we are saying that this should be theta. That means go back to our original variable dy by 1 plus y square is, we are saying that it is theta, but we know that this is what the connection between the theta and the y, right? So theta
yes,
is
sir.
nothing but a tan inverse of y. Do you see that?
Okay.
Plus an integration constant c. So we completed the integration. You see, it looks like a bit of a complicated integration, but by making it to come to a form where we go with the trigonometric help, identity help, finally it is solved within a couple of steps. You get that?
Yes, sir.
Okay, I will leave you with the limits and everything, how to go about that. Work on it and try to see whether you can solve the problem.
Okay.
So final answer, I would say that you are going to find the time as a 2 pi over 3. This is the so much seconds. Okay.
Okay.
So I will give you the answer for you. and you work on it. I will quickly tell you why the tan theta, why you did not. I go to the next page. Are you in the new page?
Yes, uncle.
Okay. So
yeah.
Let's say I have a function like y equal to tan x. Right?
Yes.
I want to find dy by dx. That is my interest, right?
Yes.
So that means what? Try to see this. Can I convert this into something which I know of, where I can proceed with the differentiation? This
Sine by cos.
That is where the answer comes from. Do you get that? So this is d by dx of sine x divided by cos x. Okay.
Uncle, I can do this by like the first principle method.
Yeah. This is always you can. That is what I'm saying. This is simply cos square x. So cos x multiplied by differentiation of sine x is cos x minus, keep the sine x, and differentiation of cos x is minus cos x. Is it minus sine x?
Cos x is minus.
You know this, right? This differentiation.
Yes.
Multiplied by our sine x, minus sine x. Is it okay?
Minus sine. Yes.
My system is getting really minus sine x. Okay. So this will look like cos square x minus plus sine square x.
Yeah.
Divided by cos square x. So
that will be 1.
1 over cos square. Yeah, cos square x. This is what we write it as a secant square.
Okay.
Same thing like so if somebody is asking us, give us sine y is equal to, for example, sine inverse of x. It could be right.
Yeah.
If somebody is asking you dy by dx, what do you do? Don't throw any formula or anything. Just to use what is available to us. Can I go to a comfortable form which will help me to do this problem? This is nothing.
Yeah, we can use chain.
Yeah, x is equal to sine y, right?
Yes.
We apply the sign on both the sides, isn't it?
Yes.
Don't you think that this dy by dx is nothing but 1 over dx by dy?
Yes, sir.
Okay, so just to go with that. So all I want is dx by dy. What differentiation of this is what? Sine y is cos y.
Cos y.
Right. But eventually I want everything in terms of x. So the y is looking not that good, but this is nothing but square root of 1 plus sine squared y, right?
Yes.
Y. So now this will be square root of 1 plus the x squared, because x is nothing but sine y.
Yes.
So now dy by dx is 1 over square root of 1 plus x squared. So that is the reason dy by dx here is going to be 1 over 1 square root of 1 plus x squared, right?
Yes.
So simply saying, if you differentiate d by d theta of sine inverse of theta, the answer is inverse of, this is nothing but 1 over 1 plus square root of 1 plus theta square.
Okay.
So anything, don't take it as a formula or anything, because try to ask question, force yourself, and always try to do that, because that will, because you may remember the formula and all those stuff as a young age now, but after a month or so, can you still remember that? So what we are learning is, do I have the ability to use the available thing, what to be done, to go to a point where the things which I will always remember. Do you get that?
Yes, sir.
So don't leave out anything. So don't memorize or force anything. Consider everything in the problem, and everything is considered, that will lead to the correct mathematical model. And it may look like straight away I can't remember. For that, you cannot always go back, I will revise and come back and get the answer. Don't do that.
Okay.
Try to use which is available. Can I substitute it or do it in a different form and get out? Do all the basic mathematical stuff first. to get to a comfortable form where we can proceed with what we could do with that. Okay.
Yes,
So
sir.
even differentiation of ln x with respect to x is what? Natural logarithm.
Ln,
Differentiate what you get. Answer. If you differentiate e power x, what do you get?
e power x will be e power x.
Okay, that also you need to question why the differentiation of e power x is always e power x. Do you get that?
Okay.
I will leave it to you. But now, what is the connection between exponential, that is e power x, and the natural logarithm ln? Like sine and sine inverse function, they have a connection, right?
Okay. Okay.
Like that, don't you think that the exponential function should have an inverse?
Yes.
That is what natural logarithm is.
Okay.
Okay, we will cover that next week then. Okay.
Okay. Okay. Okay.
Okay. Okay. Take care then.
Okay. Thank you.
Okay. Bye.